Today I'll be talking about how to do well in an MYP level 4 to 5 lab report. Today I will be specifically talking about Criterion B, Inquiring and Designing. Inquiring and Designing covers 4 sections: the research question, hypothesis, variables, and method. In a year 10 or 11 lab report, you won't be given a format, so you'll have to write paragraphs instead of writing in or filling in tables. The first strand is the research question and problem. So the 7-8 descriptor is explain a problem or question to be tested by a scientific investigation. The research question will follow the format: how does the independent variable affect the dependent variable? You will want to include 1 or 2 important control variables. So this format is shown in this example. How does the specific heat capacity affect the water temperature? And it will include some controlled variables. Your research question must be able to solve a real-life problem. So explain how this investigation can solve a real-life problem. So what is the problem, who's affected, how this investigation will solve it, and justify the importance of solving the problem with statistics and facts. So you'll want to explain why it is an authentic problem, how this certain data can help individuals who face this problem to reach a solution, and you'll have to explain why it's an important problem. Like, why is it worth studying or investigating a solution to? And you also want to summarize your current knowledge. Why do you think the IV will have an effect on the DV? Just some background knowledge so that you know that your investigation is meaningful. So here's an example I wrote in year 9. This wasn't assessed, but it was about urban heat island effect. How does the urbanization of an area affect its air temperature when measured at the same time of day? So how does IV affect DV when CV is kept the same? That's the format you'll want to use. And then I have some statistics, some information about the problems of urban heat island effect, and some of the major issues and what the investigation will be about. So this isn't a very long section. When you write it, you're just going to have to make sure that the problem is detailed and that you make sure that the investigation can solve the problem. In the hypothesis section, it asks you to formulate and explain a testable hypothesis using correct scientific reasoning. So the format for the prediction will be: if the independent variable increases, then the dependent variable will either increase or decrease depending on what you're predicting. If the independent variable values are qualitative, then you can write: if the independent variable is changed, then the DV will increase or decrease, and then list the order of variations that you're predicting. In the scientific reasoning, you'll have to explain each step. So how does the IV affect the DV? What are the steps that lead to this relationship? And thoroughly explain each of these steps using correct scientific reasoning. So you can research and back up your scientific reasoning with sources if you wish, and make sure it is accurate and appropriate science. If you don't use the appropriate science, then you might get a 5.6 instead of a 7.8 because the scientific reasoning you use might be somewhat relevant, but it might not be the correct scientific reasoning. So for example, this is a very, very brief one. It will probably only receive a level 3-4. This was not a summative one. So to get a level 7-8, I would probably have to explain what the albedo effect is, how the presence of people in vehicles can influence the air temperature, how transpiration can reduce the air temperature, etc. So you'll have to make sure that your explanation is scientific. Make sure that it includes everything about the effect of the IV on the DV, because if it doesn't, then it might not be complete. It might not make sense. The science may be wrong. So just research to make sure that all of your information is accurate. The next section, or the most important section, is the variable section. So you'll have to definitely know what your independent variable is, the dependent variable, and the controlled variables. Hopefully you know what these are by this point. Explain how to manipulate the variables, and explain how sufficient relevant data will be collected. So when you explain how to manipulate the variables, explain how you're going to change the independent variable, how to measure the dependent variable, and how to control the controlled variables. So be super, super precise with this. For example, you can't just say, put the conductivity meter in the beaker and look at the number. You'll have to say, clamp it with a clamp stand, place it so that it's in the center of the beaker, halfway down, and read the conductivity meter until the number stops changing, and record the data. That will give you a 7/8. You'll have to justify why the independent variable variations were chosen and justify why the number of trials were chosen. You don't need to make this section super long. And in the controlled variable section, you should aim for around 4 to 6 controlled variables, and you won't have to explain why it is important to control. So it is important to know that it is important to control, but it's not assessed. So all you'll have to do is explain exactly how you will keep this variable the same in all trials and all variations. So this is how you'll measure relevant data. Sufficient data will be number of trials. So ensure you include the number of trials and why you're doing that many trials too. For example, this is one of my summative pieces in year 9 for the urban heat island effect report. This was actually a summative strand. So I explained the independent variable, how to manipulate it, and why I chose the different locations, and the dependent variable, how exactly to measure the temperature. So this did get a level 8, and my teacher marked it with the MYP 4 or 5 criteria. So yes, this would earn a level 8. Trials, you'll have to state the number of trials, why you're doing this many trials. That will be sufficient. And the controlled variables, I just included an example, how to measure the air temperature. So hold the thermometer at shoulder height, 30 centimeters from the eyes. So this is specific enough for someone following this lab to be able to know how exactly to measure the temperature. For the method, it asks you to design a logical, complete, and safe method in which he or she selects appropriate materials and equipment. So first, you're going to make a list of materials and how many of each material you'll need. You'll have to select the appropriate equipment. So research if you don't know. For example, you can't use a beaker to measure volume. You're going to have to use a measuring cylinder for that. So just make sure the materials are scientific equipment and make sure that they're using for the correct purpose. Be specific when referring to materials. You can't just say thermometer. You have to say standard glass alcohol thermometer. State the precision and the units that will be used. So the tenth of a degree in degrees Celsius. And you have to state in parentheses how many thermometers you'll need. In this one, I only needed 1. Make sure the method is concise, clear, and logical. So it says design a logical, complete, and safe method. So I'll cover the safety part later. Logical and complete means there are no missing steps. The steps aren't out of order. It tells the reader how to change the IV, measure the DV, and control the CVs. It should be super clear and complete. And yeah, if your method is a little unclear, you can draw a diagram of equipment setup to help explain it. But this is not necessary, and you'll only have to do it if you have some extra time. So yeah, that's not your priority. But if your method is confusing, then you can draw a diagram on paper or on slides or Photoshop or whatever. The safety part is very, very important. If you don't have safety, the maximum you can get is a 4 on this. So make sure that you just state some safety concerns and what to do if there happens to be an accident. And yeah, so here's an example. So I give a list of the materials with the quantities, with the numbers, the precision, all of that. The method, it includes all of the steps, how to do the trials, how to do the independent variables, how to measure the dependent variable, and how to control the CVs. So yeah, that is the method. It shouldn't be too long, and if your method is concise, then it will be easier for someone to follow. Next is the safety section. So you'll just have to state some important concerns. You won't have to write a full page for this, just maybe half a page and some research. For example, aluminum chloride, what the risks are of that and how to deal if it gets on your skin. So yeah, safety, you have to have it, but you don't have to write too much for it.